Welcome back, everyone. I'm here to offer some guidance and support with your homework today. So you're going to go into the classroom and you're going to open the document that looks just like this. You're going to find that in your stream or on the calendar or wherever you like to find your homework, classwork, exit tickets. And you're going to take out a piece of paper. Okay, and you're going to work these problems out on a piece of paper. And let's see here. I'm going to work them out up here on the screen like this. And we're going to figure out a new way to do this, a little bit easier way, so we don't have to use the Pythagorean theorem twice. And maybe a little bit later we'll go into an explanation of why this works. But basically here, this right at the top, this is the same worksheet I just showed you. It says, we've been studying right triangles from a two-dimensional viewpoint. However, often triangles occur in three-dimensional settings, so they're not flat. When finding the length of a diagonal in three dimensions using length, width, and height, the formula is the square root of the length squared plus the width squared plus the height squared. Okay, so basically what that means is I don't have to use the Pythagorean theorem twice for these two different, right? Remember, we were just doing this. There's a triangle here across the bottom, okay, and I can first find the hypotenuse. I can find the length of C if I know A and B. And then once I find C, then I can find, it's just a little review of what we just did, right? Then I can find, if I know that length and I know this length, well, then I can find the hypotenuse of that diagonal triangle, right? And my C sub 2 is up there. Okay, so there are two different hypotenuses there in two different right triangles, and that's how we were finding that diagonal length. But this time we're going to do something a little bit different, like I just tried to explain there. I'm going to get all this out of here. Okay, so I've got this shoebox that's 4 by 6 by 3. Okay, so I'm just going to use this box right here for an example. So it's 6 by 4 by 3. Okay, what is the longest pencil you could fit inside this box? An empty box may help you visualize the various ways you could fit a pencil in the box. If possible, draw a diagram to show the pencil's position. Well, if it helps, take out a box and put a pencil in there and see which way it can hold the longest object. And it's from corner to corner, right? It's from this front corner to this back corner, bottom to top, right there. That's the longest thing you're going to fit inside that box. And the way we're going to find that, as I just mentioned, we're going to take the square root of the length squared, which is 6, right? So I'm going to do 6 squared, and I'm going to add the width, which is 3 squared, and I'm going to add the height, which is 4 squared. And that's going to give me 36 plus 9 plus 16, 36 plus 9 plus 16, which is 36 plus 25, which is 61. So that's equal to the square root of 61. Okay, the square root of 61 is equal to the diagonal. And the square root of 61, second square root of 61 equals 7.81. 7.81 is approximately the diagonal. So that would be the longest pencil that could fit in that box. The longest pencil would be 7.81 inches. Okay, the longest pencil that would fit would be 7.81. Longest pencil that will fit is 7.81 inches approximately. I should have put approximately first, is approximately 7.81 inches. But that'll work. That's the answer to that first question. Okay, and I could have worked that out the other way and kind of gotten to the same place. Right, but that's just a little bit faster and a little bit easier. Okay, so now I'm going to go down to this next one. This box is actually, you can see, there's a little fly right there. Okay, this next problem says a fly was sitting on the ground in the back left corner of your classroom. Okay, so I'm thinking this is the front edge of the classroom here. Right, this right here is the front edge. Okay, and it's saying that the fly was in the back left corner of the classroom. He flew to the ceiling in the opposite corner of the room. So basically what the fly did was from this corner right here, he went all the way up to that front corner, from the back left to the front right. How far did he fly if he went in a straight line? Draw a diagram of your classroom complete with the correct measurements. Okay, so for this one, we're going to just, we're going to put some measurements in here. Okay, the classroom is 22 feet wide, and it is 18 feet that way, 22 feet that way, 18 feet that way. I'm going to change that. I'm going to go 24 and 20 and 10. Okay, so if these are our dimensions, then I can use that formula that says the diagonal d of the diagonal is equal to the square root of L squared plus H squared plus W. I'll do them all in cursive letters. Okay, so length is 24, so 24 squared plus 20 squared plus 10 squared. And after I square each of those bases and add all those terms, let's see, 24 to the second power plus 20 to the second power plus 10 to the second power, I get 1076, 1076, and that's still all going to be equal to D, or the diagonal. Okay, and I'm going to take the square root of 1076, and that gives me 32.80. Okay, draw a diagram complete with the correct measurements. How far did he fly? So I'm just gonna round that to the nearest tenth. I'm gonna say 32.8. So D is approximately 32.8 feet. And that's how far the fly went. 32.8 feet is how far the fly traveled. Okay, and that's the second one. Now we're going to look at another one. Okay, it says a cone has a slant height of 17 centimeters and a base radius of 8 centimeters. How high is the cone? All right, so I'm gonna draw this thing. I'm gonna ink to shape. I'm gonna do this. Let's see what I can do. There we go. And then I'm gonna do this. I'm gonna draw myself a cone. I'm going to go just like this. There's one side. Let's see. So I've got this cone, right? And I know that the radius is 8 centimeters, so the radius is right there in the center, right? And then my radius is half the circumference, right? So let's see here. It's not perfect, but it's going to work. Okay. Cone has a slant height of 17 centimeters. Okay, so I've got 8 centimeters here, and I've got 17 centimeters here. So now, if I go from the center of that cone right up there to the top of that cone, right, what I've got here is a right triangle. And I have A is equal to 8, and B is an unknown, and C, my hypotenuse, the side opposite of that right triangle, is 17. So I have 8 squared plus B squared equals 17 squared, and I know this is 64. And I can just subtract that from both sides. 17 squared, I think, is 289. 289. And then if I subtract 64, I get 225. So B, let's see, subtract 64, and I wind up with B squared equals 225. And I'm just going to move over here. B squared equals 225. And if I want to know what B is equal to, I take the square root and I find B is equal to 15. So I know that the cone is 15 centimeters tall. And that's working with a cone. Okay. Now in the next example, you guys can pause this anytime you want. It says find the length of the longest nail that could fit entirely within a cylindrical can of radius 3 centimeters and height of 8 centimeters. Alright, so I've got a cylindrical can, right? So you're just imagining any sort of can, any soda can, right? And, you know, the bottom of that is a circle. And then you've got some sides. Right, this isn't really... I'm sure there's a better way to do this. Let's see. Shapes. Basic shapes. I'm going to figure out a way to do this here. But not right now. I'll figure it out though. Let's see. So I've got this guy. Let's see, ink to shape. And draw some lines. I'm going kind of slow here, and there's no need to be completely precise with this. Okay, it's not. And then I draw another circle. That's ugly. Let's see what I can do here. Alright, so whatever. We've got this three-dimensional can. It's a cylindrical can. It's got a radius of 3 centimeters, right? So that's going to be 3 right there. And a height of 8 centimeters. And I'm trying to find what's the longest thing I can fit in there. So I want to know what's going to fit from that corner to that corner. So what I actually need is a circumference. And the circumference is 2 times r, right? Circumference is equal to 2 times the radius, and the radius is 3. So c equals 2 times 3. So c equals 6, right? That's the circumference, and that's going to give me my other leg down here. So I have a 6 centimeter leg and an 8 centimeter leg, and I'm missing the hypotenuse, this side right here. Sorry about that. So what we're going to do, we're going to take 6 squared plus 8 squared equals c squared. And that's going to, c is going to be the longest nail that will fit in there. And 36 plus 64 equals 100. So c squared equals 100. And the square root of 100, the square root of 100 is equal to the square root of c squared. So 10 equals c, the longest nail that will fit. Longest nail that will fit is 10 centimeters. And the longest nail that will fit, the longest nail that will fit is 10 centimeters. And that's that one. And I'm going to go on and do one more with you here, okay? Determine the length of the longest piece of timber, which could be stored in a rectangular shed 6 by 5 by 2. Alright, so I have a rectangular shed. The dimensions are 6 by 5 by 2. And I know that d is equal to the square root of L squared plus H squared plus, bringing back that cursive, W squared. Okay, length is 6 plus height is 5, or height is 5, and width is 2 squared. And so 36 plus 25 is 61, plus 4 more is 65, so the square root of 65 is equal to d. So the diagonal is going to be just a little more than 8, because 8 times 8 is 64, so second root 64, second root 64 equals 65. 8.06. D equals 8.06 meters. 8.06 meters is the longest timber that will fit. Okay, and that's pretty much the first page. Remember, if you have a three-dimensional shape and you're trying to find that corner to corner in that rectangular cube, you can just do length times height times width, square all those, take the square root of the sum of each of those values, and that'll give you the length of the diagonal. And that's all I'm going to do with you guys. You're going to keep working on your own. Good luck, have fun out there. I hope you're all safe and happy.